Here in this video, we would like to discuss how can we get a maximum power transferred when a battery is connected in a circuit. So, let us imagine a battery. This is the battery with a positive plate and negative plate. This battery has some EMF E. It is connected to a external resistance, capital R. But this battery also will have some internal resistance R. Because the battery is not ideal, it always has some kind of a internal resistance. So in this case, what is the way that we can transfer the maximum power, right? If I have to find out how much maximum power is transferred, I should first of all write what's the equation for the power is. We know power is rate of change of work done, that's work done by time. In terms of potential, we know potential is defined as work done in bringing a unit positive charge from infinite distance up to a particular distance. That implies work done can be written like VQ. Substituting it in the above equation, this, we can write power as potential into charge by time. Charge by time is rate of flow of charge, that's nothing but current. We can write as per the Ohm's law V equal to IR, and there is another I, this one. So power formula is I square into R. We have derived this earlier also, but for convenience, right now I have derived for you. Now, if I need to know the power, I shall know what is the current is. So current always starts from the positive plate of the battery. It goes to the external resistance, then through the series internal resistance and comes back to the negative plate of the battery. As per the Ohm's law, current is total V equal to IR with Ohm's law. As per the Ohm's law, current is equal to total voltage, that's the total EMF supplied, by total resistance of the circuit. This external resistance and this internal resistance are in series. When the resistors are series, total resistance is nothing but capital R plus small r. I know the value of I in this equation now, so I can find out what is the power is now. So power is equal to I square. I means this value, E by capital R plus small r whole square multiplied by external resistance. This is the power. Now we need to calculate when this power could be maximum. For the power to be maximum, for any function to be maximum, differentiation of that function with respect to variable. What we can vary is here external resistance, because internal resistance of a battery is constant. So differentiation of the power with respect to external resistance has to be equal to 0. So what is that power equation this much? See, differentiation of that power is nothing but equal to differentiation of power with respect to external resistance is differentiation of this value, E square R by capital R plus small r whole square has to be equal to, but of course as E is constant, differentiation of E square also will become constant. That implies d by dr of R capital R by capital R plus small r whole square has to be equal to 0. This I have to identify. This is like in a differentiation of U by V format. I can write what is the formula for the differentiation of U by V. You know, we have learned in differentiation. It is U into differentiation of V minus V into differentiation of U by V square. So I have to write this value, right? So of course, differentiation of U, this is U and this is V now. So differentiation of P with respect to R will become automatically, in the place of U, I will write U itself. Differentiation of V, that is differentiation of R d by dr of capital R plus small r whole square minus V, that is capital R plus small r whole square, and differentiation of U, that is differentiation of u r by of course v square has to be equal to 0 as per this relation. So if I equate that to 0, the denominator term go to the other side and becomes 0. Then u d by dr of capital R plus small r whole square minus capital R plus small r whole square differentiation of r by dr is equal to 0. So let us simplify this further. So how it can be simplified is, let us simplify this. In the place of u, I have missed one small thing here. In the place of u, I have to write u. What is u? This is r. So in the place of u, actually I have to write r. Yes. So r differentiation of x power n, we know this, n into x power n minus 1. Let me use that formula. Differentiation of r plus r whole square, that is whole power to n is 2, r plus r whole power of n minus 1, that is 2 minus 1. Here r is variable, partial kind of differentiation, minus r plus r whole square dr by dr is equal to 1 equal to 0. Then what happens? r 2 into r plus r whole power 2 minus 1 is 1, dr by dr is equal to 1. This minus term we can take to the other side, r plus r whole square. So 2r of r plus r is equal to r plus r whole square. So 2r of r plus r as r plus r whole square as r plus r and r plus r. One r plus r can be cancelled. So what is remaining is 2r is equal to r plus r. Get this r to this side. That implies capital R equal to small r. So for the maximum power transfer in any device, in any circuit, we shall have an external resistance value that's equal to the internal resistance. In that case, we can get the maximum power transferred in the circuit. That's how we have to solve this or understand this. Thank you for watching.